Hello everyone. So today we are going to do the question sum of pairwise Hamming distance. So this was a question which was being asked in Google, and this was the same question which was being asked in Nokia online assessment which I gave few days back only. So today I was solving this question, so I thought just I should make a video tutorial for the same because it is pretty much interesting question. So, before solving this question, what we need to know is that what the Hamming distance is. As the question itself states that Hamming distance between two non-negative integers is defined as the number of positions at which corresponding bits are different. When we read this statement, the first thing which comes to our mind is regarding XOR of two numbers. But it is somehow similar to that, but doing XOR won't be one of the option in this question. So what all we need to do is have written about Hamming distance and example here. So what we need to do is that we are given with an array. In this question only it is given that we are having an array which is having elements 2, 4 and 6. So first what we can do is we could simply write all those elements in the bits form. So here the bits form of all three would be like this. So next, for pairwise Hamming distance. So in simple words, pairwise Hamming distance refer to the number of different bits in a particular pair. A pair could be with a number itself also or any other number which is given in that array. So if we take 2 comma 2, then what would be its binary representation? It would be 0 1 0 and 0 1 0. So when we'll see both of them are same, so the number of bits which would be different would also be 0. So the Hamming distance between both of them would be 0. When we come to the example 2 comma 4, in this part, representation of 2 in the form of binary is 0 1 0, and for that 4 is 1 0 0. So we are having 2 bits different in this pair. LSB same 0 and 0, but the middle bit which is 0 in the 4 and 1 in the 2, so it is different. And the MSB, which is 1 here in 4 and 0 in 2, and it's different. So here we are having two different bits in this pair. One more thing which we need to check is that if it's 2 comma 4 or it's 4 comma 2, the bits would be same in both of them. So if we write 2 comma 4, 4 comma 2, coming distance between both of the pairs would be same. So we would be having some numbers which will occur twice pairwise. This is one of the things which could be used in upcoming solution. Alright. Then another example could be for 2 comma 6, where if we write bit in the form of 0 1 0 and 6 in the form of 1 1 0, then the bit which is different is our MSB. Here it is 0 and here it is 1. So only one bit difference is there. So our Hamming distance would be 1, and same goes for the 6 comma 2. Like this only we are having 4 comma 6, where 4 could be written as 1 0 0 and 6 could be written as 1 1 0, and here the bit which is different is our middle bit. Here it is 0 and here it is 1. So same goes for 6 comma 4. So we would be having one bit different in this pair. Likewise, we could write Hamming distance for all pairs of the above array, which could be written as, like, first we need to check for 2 with all the elements, then we need to check for 4 with all the elements, then we need to check for the 6 with all the elements. So one more thing which we could encounter is that all the diagonal elements are in the form that they would be having 0 as their Hamming distance. And another thing is that 2 comma 4 and 4 comma 2, these are the elements which are being, these are the pairs which are being repeated. So we could simply write them as in the form of 2 into f of 2 comma 4, and for 2 comma 6 and 6 comma 2 we could write them in the form of 2 into f of 2 comma 6, and same for the 4 comma 6. So then I have written all those which are having zero Hamming distance like this 2 comma 2 and 4 comma 4 and 6 comma 6, and all those which are encountering as in pairs, I've written them in this form. And then our final answer, that the first three pairs are having zero as they are having distance. The next three pairs, two in common to them, we are having the Hamming distance for 2 comma 4 as 2, and then for 2 comma 6 as 1, and then 4 comma 6 as 1. So at the end we are having the answer as 8. So for the input of 2, 4, 6, we are having the answer as 8 as given here also, that when we are having this, so we would be having output as this. So now the next thing, how we need to implement this in the form of code. Like if we would be counting each and every pair like this only, that first we need to count for 2 comma 2, then 2 comma 6, then 2 comma 4, and say going with other elements, then surely it would be a long process. So in spite of doing it in the form of that manner, what we could do is that as we need to know about bits only, so we would be checking set and non-set bits of all three elements simultaneously. First, we will be checking for the LSB of all three elements, that if they are set or non-set, and we'll simply multiply them together. And at the end, we need to do it twice of that, because there are pairs which are occurring twice. That's the reason we are multiplying it with 2. And then we will be doing all that for all the bits till 32, and at the end whatsoever would be our answer at the end, we'll simply add all of them, and then this would be our final answer. Here what I had done for the bit which is at the position of 2 raised to power 0, means LSB, I have checked the number of bits which are set are 0, because all are 0 in their binary form when it comes to LSB, but non-set bits. Non-set bits are 3, because all of them are 0, so it's counted 3. And then we are multiplied by 2. And for when we go to the middle bit, that is 2 raised to power, which is at the position of 2 raised to power 1, our set bit is 1, and then here it's 0 and 1. So we have two set bits. I have written 2 at the place of set bits, and we have one non-set bit, so we have written 1 at this place. And at the end I have multiplied all three of them and got 4 as our answer. And then for the position at 2 raised to power 2, we are having one bit which is non-set, then second bit which is set, then third bit which is set. So we are having two bits which are set and one bit which is not set. So I've written in this manner, and as it could occur twice, so I've simply multiplied by 2, and so at the end we are getting 4 as our answer for this particular position of bits. So at the end what I need to do is simply add all of them, 0, then 4, and then 4, so our answer would be 8. Now this was a thing which I need to implement in the form of code. So before moving to code, what all it was that we need to know the Hamming distance, and after that what we need to know is that how we need to implement that in the form of code. Now the part of the code. So first we are taking a result variable, in which we would be returning our end answer after taking it of the type long. But as a return type is int, so at the end we want answer in the form of int. And for that I had already did it modulo with 10 raised to power 9 plus 7, so that if I, because also in this question it was written that I need to return the answer modulo 10 raised to power 9 plus 7, because our array input could go to the form 10 raised to power 9. So we don't need to exceed the int. That's why we are doing modulo with 10 raised to power 9 plus 7. So first thing, in this first question, we are moving from 0 to 32. Means checking for all the 32 bits. We are maintaining a count on variable which will have the count of all the set bits of that particular position of all the elements simultaneously. We are maintaining one more loop inside it, and this loop would be checking for all the elements in the array. For example, if we are taking that 2, 4, 6 only, so first it will be checking for 2. In that we are having 2, and for 2 that uh, 2 could be written in the form of India 010, so our least significant bit which is 0, and when, so 0 would be checked, 0 would be checked here, and if we do and with 1, which would simply return in 0. So here as it is not set, our countdown would not be increased, and same will check for 4, and then we'll check for 6. So here our countdown will not be increased at this moment, so our countdown will be 0. So our countdown will be 0, and then for checking our count off, what we'll be doing is we'll check for the size of the array and simply subtract countdown from it, and then by this we'll be getting the number of non-set bit. At the end we'll be doing multiplication of all 2 and doing it twice. So for this number of set and non-set bit, we'll simply add this to the result, and then our loop will move on to the next number, and in that we'll check for our second bit, that is 010. So here we'll check for the 1 when it's about 2 in 1, and at this moment our 1 which is here shifted with 1 only, it will simply move to 0, 1, 1, 0 like this. Then we'll be doing and it will simply result in 1 only. The bit is set in at this moment, and our countdown will also increase at this moment. So like this all the bits will be checked, and at the end we'll be having the answer. Sorry, I tested and I added commented, so it will be showing error. So how will this then surely we'll get our answer as correct. So this is how Hamming distance could be calculated. So thank you.